Chapter 5 is about rational functions, which are defined like this, where basically what they look like is one polynomial divided by another polynomial. So we've had functions that were just a single polynomial, now we've got one divided by another. The graphs can look a little wild, actually. So this section and the next section are mostly about graphing, and this section really focuses on a couple of graphs that tend to show up a lot, or a couple of rational functions that show up a lot, 1 over x and 1 over x squared. So the first one that shows up is 1 over x, right? I mean, there it is right there. And if you plot some points, so if you want to plot points to see what the graph would look like, then these would be, I think, the easiest ones to graph, where I also think that's enough to kind of get a feel for what this thing would look like. So if you put 1 in for x, so you substitute in 1, you're going to get 1 over 1, which is 1 for f of x. If you put in 2 for x, you get 1 half. Put in 1 half, then 1 divided by 1 half is 2. And then similar sorts of things happen here just with negatives. And if you plot those points, so there are the positive ones, there are the negative ones, this is the shape that you get. And then you think, well, why does it look like that? Like, why doesn't it connect together? Right? Why are the two pieces totally separate? Well, first of all, there's no way for the function to be 0, right? Because you've got a 1 on top, right? There's no way that 1 divided by anything is ever going to be 0. So there's never going to be a point that's right on the x-axis. That's going to be impossible. The other thing is the function is undefined when x equals 0, right? If you sub in a 0, you're going to get 1 over 0. So the function's never going to touch the y-axis either. So if it's never going to touch the x-axis, it's never going to touch the y-axis, then we're getting positive x values and positive y values at the same time, like those 3 points. This part of the function is going to be confined within where these axes are, because there's no way you could have a function value of 0 and you can't have x being equal to 0 here because the function's not defined. So this piece is just sort of like sequestered up there in the first quadrant. And the same thing happens down here. This one is entirely going to be in the third quadrant because it's not going to cross or touch the x-axis, and the function's still undefined at 0, so it's not going to touch the y-axis either. And then notice that as the function gets closer to 0, then it goes in opposite directions, right? On the right side, if you get closer to 0, it's going up, because then, or if you take a really tiny positive number like 0.00001, 1 divided by that is huge. So it's way, way up there somewhere. But then if you take a negative number that's very slightly less than 0, like negative 0.0001, then you're going to get a negative 1 divided by that. So your function value that you're going to get, it's a negative number with a huge absolute value. So it's way, way down there somewhere. So generally, that's what the graph of 1 over x looks like. And the other stuff off to the side, so the domain and range, everything except for 0, that sort of came up already. Right? You got to leave 0 out of the domain because the function's undefined when x equals 0. And for the range, you're never going to get a function value of 0 when it's 1 divided by something else, right? With the 1 on top, you can't get 0. Then decreasing in both parts, right? If you go left to right, that's going downward, and then that's going downward. And it's an odd function, meaning it's symmetric about the origin, but just kind of eyeballing that thing, it looks like it's symmetric about the origin. Then this is a new concept, and it's going to show up a ton in this section. Although I guess it also showed up a little bit in chapter 6, because the natural log and exponential functions have these, but this is going to be a lot more common now. The idea of an asymptote. So like it says here, as x is approaching 0 from either direction, so either that way or that way, then the absolute value of f of x approaches infinity. Right here it's approaching infinity. On the left side it's approaching negative infinity, which the absolute value, that's positive infinity. So the graph that's up there, the graph of f of x equals 1 over x, the line x equals 0, which we normally call the y-axis, is a vertical asymptote. So with an asymptote, that's what happens, at least with a vertical one. It doesn't have to be it goes up on one side and goes down on the other. They could both go up, they could both go down. But on either side, the function values, or I guess the absolute value of the function values would approach infinity. So the function values approach either positive or negative infinity. Then we also have a horizontal asymptote, because as x is approaching infinity and negative infinity, f of x approaches 0. Right? If you keep going out to the right here, this gets lower and lower and lower, but it's never going to touch the x-axis. Over here, if you keep going off to the left, it's the same sort of concept. This keeps going up and up and up. It gets higher and higher, but it's never going to touch the x-axis. But the function values, they're going to approach 0 either way. So if you're going way off to the left or way off to the right, and that's something called a horizontal asymptote, where the end behavior of the function, where you have x values that are really big in terms of absolute value, so either approaching positive or negative infinity. If the function gets closer and closer and closer to some value but never actually gets there, then that's going to be a horizontal asymptote. Next thing is that you can have shifts and stretches and those sorts of things just like we had in chapter 2. That's basically what this is like. So here, 1 over x plus 2, that's a vertical shift up 2 just like it was before. So in the graph, notice my horizontal asymptote got shifted up 2. It's not y equals 0 anymore, now it's y equals 2. And then all the points got shifted up 2. So basically all I did was I took the points from up above and added 2 to each of the y coordinates to get the new ones. But that's what it would look like. It's the same graph as up above, just everything shifted up 2 units. This one here, when you have x minus 4 instead of x, remember from back in chapter 2 how if you replace x with x minus something, like an x minus 1 or an x minus 4, an x minus 10, that's a shift to the right. So a shift to the right of 4 units. So if you have 4 to the right, now my vertical asymptote is x equals 4, right? Because for the function up above, for 1 over x, it's the axis, so you got to shift over 4. And then all the points are going to shift over 4. So I just added 4 to all the x coordinates, and then it's the same shape, right? Just all the points shifted over, but it's the same overall shape as it would be for just 1 over x. And then here's a stretch. So just like before when we had these, this is basically going to work the same way. 3 over x, you could rewrite as 3 times 1 over x, and you can say, oh, well, then it's going to look like 1 over x, except there's this vertical stretch. So in order to get the new points, you could just multiply all of the y coordinates by 3 from the basic function, and then you get this sort of thing. All right, well, I guess that takes care of the ones that are sort of conventional. Number 4 and number 5 are a little weird, because you look at that thing and you go, that doesn't look like a transformation of 1 over x, right? Where's the 1 over x in this? And x minus 2 over x minus 3. Well, if you divide, like if you actually go through and do the long division like I did here, where I divided x minus 2 by x minus 3, and I said, all right, multiply 1 by x minus 3, you'd end up here, but then you're going to get a remainder of 1. So you could write f of x as 1 plus, and there's the remainder up there, right? The 1 over x minus 3. But this thing is a transformation of 1 over x. Because you can say, well, we've got x minus 3 instead of x. That's a horizontal shift. And then you got a plus 1. That's a vertical shift. So it's 3 to the right and 1 up. So I wrote out the original points for 1 over x, and then with both transformations. So I added 3 to the x coordinates and added 1 to the y coordinates. And same things with the asymptotes. So if we're shifting 3 to the right, then the vertical asymptote's got to shift over by 3. So x equals 3 is now a vertical asymptote. And then horizontal asymptote's got to go up by 1, right? Because we're going 1 up. So now we've got a horizontal asymptote of y equals 1. And then I did the transformations on all the points. So plus 3 on the x coordinate, plus 1 on the y coordinate, and then just plotted those. It's the same overall shape, right? Just moved over and then moved up a little bit. But getting from here to here, I think, is the important step, right? Because if you look at this thing, it is not obvious what that is, right? It's not clear that that's just a couple of transformations on 1 over x. But if you do the long division, then here it looks that way, right? Here you can see it. Then number 5 is another one of these where you look at it and you go, that doesn't really look like a transformation of 1 over x, but if you do the long division, which I did here, so 2 times x plus 2 will give you 2x plus 4, you subtract 5 minus 4 will give you that remainder of 1. So this is 2 plus 1, all right, there's the remainder, over x plus 2. But then in terms of getting from 1 over x to here, then that's a shift of 2 to the left, right, because we've got the x plus 2 instead of x, and then a shift 2 up because of this plus 2 on the end. So 2 to the left and 2 up, so if we're going 2 to the left, the vertical asymptote's got to go over 2, so I've got x equals negative 2 as a vertical asymptote now. Horizontal asymptote's got to go up 2, so instead of y equals 0, I've got y equals 2. And then for the points, I just said, all right, subtract 2 from the x coordinates and then add 2 to the y coordinates, and that should be enough to do it. And if you do that, you end up with these points over here, and you plot them, and that's where you end up right there with that graph. So again, same shape, just moved over and then moved up. The other common rational function that shows up in this section is 1 over x squared. So we can plot some points, right? 1 over 1 squared is 1. Negative 1 squared is 1, so 1 over negative 1 quantity squared is going to be 1, right? But then here, 1 over 2 squared is 1/4. And then 1 over negative 2 squared is also 1/4. 1 over 1/2 squared, well, 1/2 squared is 1/4. 1 divided by 1/4 is 4. Same kind of idea here. You square negative 1/2, you get positive 1/4, and 1 over that is 4. If you plot those points, you're still going to have the same asymptotes because, once again, there's no way to get a function value of 0, not with a 1 on top. So you're going to have that horizontal asymptote of y equals 0. There's no way you can possibly get a value for 0. Or you're never going to get f equal to 0. I guess that's what I was really trying to say there. And then the other thing is that this is undefined when x equals 0. So you're still going to get that vertical asymptote. Notice that this time both sides go up when they're approaching the vertical asymptote. That's fine. You can have them both go up, you can have them both go down, you can have one go up and one go down. Another thing is this one is a little harder to draw just because it gets so steep and then it gets so flat very suddenly. So this is a tougher one to draw, and I think when you're drawing these, you don't really need to plot a ton of points. If you just know what that shape is, I think just plotting the 1, 1 and the negative 1, 1 is probably enough. And then if you just know that this is symmetric about the y-axis, that's probably going to be enough to get through it. So the domain, everything but 0, right, because the function is undefined there. The range is positive real numbers, right? There's nothing down here this time. So everything's up above the x-axis, so positive real numbers. Increasing on the left side, or as you go left to right, this goes up. Decreasing on the right side. And then the last thing is that this is an even function, and you can tell by looking at it that that's symmetric with respect to the y-axis, which is what even functions are. The next thing is a couple of transformations on 1 over x squared. So this first one is a vertical shift 3 down. So I just took the points from the last page, subtracted 3 from all the y coordinates, and I only boxed in these 2 points because that's all I plotted. And I think to graph these, this is really all that you would need. And I think the corresponding points for anything involving 1 over x is probably enough too, just as long as you know what the shape is there. But here, these are so tough to draw that I figured as long as you can get those 2 points in the asymptote, you can get the rest of it. And really 2 asymptotes, but you don't have to draw in the y-axis, right? It's already there. But because you're shifting 3 down, then the horizontal asymptote's not going to be y equals 0. Now it's going to be y equals negative 3. And then the 2 points I plotted were 1, negative 2, and then negative 1, negative 2. And that's enough to figure this out, right? The vertical asymptote's still going to be x equals 0. It's still going to be the y-axis. And you know what the horizontal asymptote is. And if you just have a general idea of what that shape looks like, what that graph looks like, that there is enough to get the right thing. Then one last one. This has got a couple of transformations. We've got an x plus 2 instead of an x. So that's a shift 2 to the left. But we also have a negation. So we're really negating the function value, right? Because you can put that out front. So if you're negating the function value, you're negating y, so that's a reflection through the x-axis. But in terms of trying to get the points for it, you would negate y. So with the points, if you're going to go 2 to the left, then you're going to subtract 2 from all the x-coordinates, and then negating y, you're just going to switch all the signs around, which I guess would just turn all these what used to be positive numbers into negative numbers. Then let's see, as far as the asymptotes go, there was no vertical shift, which means that the asymptote of the x-axis, or y equals 0, is going to stay in the exact same spot. But the vertical asymptote's going to move over because we've got to shift to the left by 2. So instead of x equals 0, we're going to have x equals -2, that dotted line right there. And then, once again, the 2 points that are boxed in are the only 2 that I graphed. So there's -3, -1, there's -1, -1. And just knowing those, knowing where the asymptotes are, and that this thing is going to be symmetric about that vertical asymptote should be enough to give you the right graph here.